Hello friends, in this video today we will study a complete design of flat bell. First we will study a type 1. There are two type in the flat bell, two types of numerical. Type 1 is when expected life is given, and next the second type is when expected life is not given. So today we will study when expected life is given, type 1. So let's begin with the question. So question is designed for a flat bell drive to transmit 7.5 kilowatt at 960 rpm, output speed 400 rpm and central distance is 1.3 meter. Expected life is 2000 hour. So this is the question. So from question now we will remove all the given data. So given data is transmit power. Power is given, which is rated power is equal to 7.5 kilowatt, which will convert into watt, which will 7.5 into 10 raised to 3 watt. And RPM given, N1 is given, which is input speed is given 960 rpm, while output speed is given 400 rpm. Central distance is given, which we will denote as capital C, is equal to 1.3 meter. Expected life is given, which will be denoted as LH, is equal to 2000 hours. So this is the given of our question. What are the given data from our question? Okay. So now moving to the step 1. Step 1 is design power. Design power. So design power, for design power is denoted as this P in the bracket is equal to RP into SF. RP is the rated power which given in the question 7.5 kilowatt. So RP we got SF is the correction factor, and correction factor is 1.3. okay, so correction factor is 1.3, which you will get from PSG 7.53. there is an table load correction factor on PSG for 7.53. assume their intermediate load. Okay, for intermediate load correction factor for that value is 1.3. so we will substitute this 1.3 over here. SF will be 1.3 is equal to, after substituting we get the design power, which is 9.75 into 10 raised to 3 watt. So in first step we found the design power. In this step we will finalize the size of pulley for driver as well as for driven pulley. For both pulley we will do. So now for first we will go for driver pulley. So from PSG 7.53 on this page number, selecting an optimum belt size, belt speed, we will select an optimum belt speed on PSG 7.53. you will go, there is one bold heading where belt speed is given. There is a they are given the range, which is 17.5 to 22.5. this is an optimum belt speed range they have given. Select any of that. We will select 20 meter per second value for V. Okay, so V is equal to pi d n1 upon 60. We know the value of V, which is 20. D is unknown. For driver pulley it will be denoted as driver pulley. D is unknown. N1 we got here, which is given in the question, which is 960 rpm upon 60, and on this solving we get D is equal to 0.397 meter converted into mm, which is 397 mm. But this diameter of pulley is driver pulley is this is the calculated value, but we have to select a standard value. So for selecting the standard value, go on PSG page number. You go there, you will see a table of a list of standard pulley diameter. You will see a table. So select the nearest value of 397. Okay, select the nearest value of 397. So here the nearest value of 397 is 400. Okay, that is 355 and 400, two value. Between these value this 397 come, but the nearest value is 400, so we will select this 400. So our driver pulley, diameter of driver pulley will be 400 mm. This is the standard value. Okay, then as we know the standard value of the, now we know the standard value. Okay, so again in the same formula, as we have now this belt speed v is equal to 20, we have assumed 20. Okay, it is not the exact value, so we have assumed. So now we know the diameter. Now put the value of diameter d is equal to 400 and n1 960, which is given in the question, and solve it again. You will get the exact value of v. So exact value of v will be 20.11 meter per second. Okay, velocity ratio. Okay, so it will be exact velocity ratio you will get. So you have done for the driver pulley. The same procedure will go for the driven pulley. For driven pulley, d is equal to d into n1 upon n2 into efficiency. This formula you will get on PSG page number 7.61. On 7.61 you will go this formula you will get, where small d you have got this 400, n1 you know 960, n2 also you know, n1 and n2 has given 960 and 400. Put the values. Efficiency you take 98%, you can take as in this PSG 7.61, their efficiency value is given 0.98, so you can assume that. Okay, so after solving this you get the diameter of driven pulley. So you get the diameter of driven pulley, which will be 940.8 mm. But this diameter of pulley is the calculated value, but we want the standard value. So for same procedure, go on PSG 7.54, select the nearest value of 940. So for the nearest value of 940 will be 900 and this 1000. Between these the value come. This 940 is between these 900 and 1000. So 1000 will be little far, but 900 is the nearest value. Okay, so we select the 900 value. So nearest value is 900. So diameter of pulley will be for driven pulley will be 900. So in step number 2 we have done calculated diameter of driver pulley as well as for driven pulley. Okay, so moving to the step number 3. Step number 3 is to find the length of belt. This formula you will get for the you will get for from PSG 7.61. On 7.61 you will get this formula. So formula is L is equal to 2c plus pi by 2 into d plus d minus d upon 4. C is the center distance given in the question, which is 1.3 meter, and capital D and small d. Capital D is driven pulley and small d is driving pulley. Okay, so keep all the value here and you will get the value of length of belt. You will get the value length of belt will be 5.012 meter. Okay, so in step number 3 we found the length of the belt. Moving to the next step, step number 4 is the selection of standard belt cross section using life criteria method. So we will select the standard belt cross section using life criteria method. So here belt material will be fabric rubber belt. Okay, belt material we are using is fabric rubber belt. So first in this A part will come LH. LH denotes as life in R. Life in R given in the question, which is 2000 hours. So put LH is equal to 2000 hours. So next B part. In B part we will find the life stress cycle. Okay, this stress cycle, life stress cycle formula is V upon L into number of pulley into LH into 3600. Okay, so here V is the velocity ratio, which is 20.11. Then L we have found in previous step, which is 5.012 meter. Number of pulley, as we have here number of pulley 2, which is driving pulley and driven pulley. So number of pulley will be 2. LH will be life in R, which is 2000 given in the question. Next 3600. After solving this you will get the life stress cycle value, which is 57.77 into 10 raised to 6 cycle. Okay, next we will coming to the C part, which is maximum stress to allowed in belt so as to have expected life. So now we will find maximum stress which is allowed in a belt to have an expected life. Okay, so formula for this is a sigma minus 1 upon sigma max raised to m is equal to LC upon 10 raised to 7. LC will be LC value will be this life stress cycle. Okay, this is just the LC value. Okay, next m is for m, value of m will be 6 for the flat belt. Okay, 6 for the flat belt, and sigma 9 is sigma minus 1, this will be 9, as you or this value will be always 9, you have to assume it 9 always. Okay, then sigma max you have to find, put all the value, you will get the sigma max. So sigma max we are getting 6.718 Newton per mm square. Okay, now moving to the next part, which is D part. Well, we will find belt cross section. So belt cross section we will find, so formula for that is sigma max is equal to T1 upon B into number of belt plus E into number of belt upon D plus rho into V square into 10 raised to minus 6. So sigma max we have got in the earlier step, which is 6.718 T. So now here T1, so where T1, for T1 there is one formula, T1 upon T2 is equal to e raised to mu theta. So here mu value will be 0.25, and theta formula, for theta there is one formula which is 180 minus 2 sine inverse into d minus d upon 2c. This capital D will be for driven pulley and small d will be for driving pulley. Put all the values we have calculated before, put all these values. C will be a central distance, put this value also given in the question, put all the value, you will get theta which will be in degree, but convert it into radian because we want answer in radian. Okay, so theta you will get theta is equal to 2.81 radian. Then on solve, then putting all the values in this equation. Okay, putting all the values here, so you will get T1 is equal to 2.017 into T2. Okay, this you will get. So there's another formula, P is equal to T1 minus T2 into V. We know the design power. Okay, value of design power we know. T1 we know, T1 we got here 2.017 into T2 minus T2 into V, velocity also we got 20.11. Put all the value here, you will get T2. Okay, T2 you will get 476.7 Newton. As you got the value of T2, put the value of T2 here, you will get the value of T1 also, which will be 961.56 Newton. Okay, so you got here T1 and T2 value, put here T1 value. Okay, then now B, sigma max we got 6.718 is equal to T1 we got here, putting T1, B into NB, put as it is B into NB. Then E value is 100, number of belt we don't know, put as it is, upon small d will be 400, plus rho this is the density will be 1200, which we assume 1200 density. Okay, velocity we know 20.11 will be the velocity as we removed before, into 10 raised to minus 6. As we put all the values here, okay, we put all the values. So here unknown is number of belt and B is the unknown. Okay, so now how you will find this? So from PSG, go on PSG page number 7.52. As you go there, you will get one table. At the bottom there is one table, minimum pulley diameter in mm for the speed, for a given speed and belting flies. So make this table. Okay, make this table. This is number of flies, then B calculated, and B standard, and finally is B standard into B number of fly, B standard into number of flies we will multiply. So number of this column will be number of flies, copy as it is, which given in the page number 7.52. 3 4 5 6 8, 3 4 5 6 8, copy as it is. Next we will calculate the b, this value we calculate. Okay, so as first we will go for 3. So put the value of number of flies, this number of flies put here 3 and here also put 3. On solving we get the b calculated, we will get b which will be 58.28. okay, so same procedure will be all, calculate for 4 5 6 8. okay, you hope you these two column you has understand. Okay, now for next you have to put the here value 4, here also 4, solve it, you will get the value of b which will be 45.74. again put here 5 and here also 5, you will get the value of b which will 38.74. okay, so like this fill this two column. As here this two column has finished, go for the third column. Third column will be selecting b standard, as this is calculated, this is the calculated, so we have to select the standard. So for selecting standard there is one table I am showing, on that page itself only this table is there. See these, see number of flies which we have got. okay, this is the 3 4 5 6 8 which we have written here on this first column. okay, same in data book you will see like this. okay, so you got this. So now for selecting a standard, now I am talking for this column. okay, how to select this. So now you got the calculated value 58.28. okay, so 58.28 we got. For how much number of flies is 3, number of flies is 3 and value got 58.28. so take next value. okay, so see 3 flies, so 58.658, next value is 63. okay, the value is 63, so we select 63 star 63 1 star. okay, so now I am saying what is this star. So this star, these size are available in high speed and fault. okay, for double star these size are available in high speed only, whereas 2 star these size is available for high speed, and for 1 star these size is available for high speed as well as for fault, and whereas 3 star these size are available for only fault only. okay, so same procedure will be for other also. Now for 4 flies, 4 flies you got 45.74. see this column 4 flies, what value you got 44.4, 44 you got. So next value of 44 is 50, so select this. okay, you will select 50. Next for 5 flies you got 38.74, 5 flies then 38 you got, so next value is 76. okay, so select 76. Next 6 flies you got 33.74, 6 flies 33, next value is 100, so select the 100. okay, now 8 flies 20, you got 28, so for 8 flies next value is this 200, so select this 200. okay, so this whole you can see the this whole on your data book page number 7.52. on page number 7.52 you will get all this, you can see this values. okay, as you know, as you got this column finished, this column no, and this column also done. Now last column is b standards, this 63 into number of flies which will be 189. same you will 50 into 4 200, 76 into 5 300, 100 into 6 600, 200 into 8 will be 1600, and last column also done. okay, so from these we will select, to selecting 63 mm we will select these. okay, 63 mm and wide and number of belt 3. so our number of belt या number of flies also you can say, we will select 3. so okay, we selecting these 3 and 63 because it is the it can get very easy and cost also will be less. okay, so we selecting these.